Well, welcome everyone to the third Making the Most from Nitrogen Project webinar series. Today we are again with Professor Richard Eckard, or Richard, and also Associate Professor David Rawlings from QUT, or Dave. And they'll be presenting to us over a number of sort of 4 sessions today, focusing in on nitrogen budgeting, and especially around the Rye Kikuyu transition and carryover period, and looking at the relationships between the two in terms of the decisions to be made around nitrogen application and the functioning that's going on in the soil and plant use. So just a reminder about this webinar series. It is supported and run by the local land services of the Hunter region, with support from the More Profit from Nitrogen program. The More Profit from Nitrogen program was a research program over the last 4 years in which both Richard and Dave conducted research looking at dairying systems and the use of nitrogen in an efficient and effective way. So just a reminder also that this is all, the More Profit from Nitrogen program in partnership with Dairy Australia has actually developed up new FertSmart nitrogen guidelines and a very helpful FertSmart nitrogen pocket guide, both available from the FertSmart website. So you can go to Dairy Australia's website and that'll throw you across to FertSmart. And all the work from the More Profit from Nitrogen program that Dave and Rich are talking about today has actually been used to inform these guidelines. So just again, acknowledging Hunter Local Land Services and also the Australian Department of Agriculture, Water and the Environment through their Rural R&D for Profit program that supported the research behind today's webinar. So Richard's just going to give us a bit of an overview about nitrogen budgeting. It's really just reinforcing some of the things we talked about in the last 2 sessions, but it's integral to sort of understand this before we head on into this topic today. So over to you, Richard.
So thanks everyone, I'll give a bit of a general overview in this first section, just talking about nitrogen budgeting, what comes in, what goes out. Nitrogen rules for maximum efficiency. We come back to the 4 R's. We keep reminding at the beginning of all these webinars, it's the right source, the right rate, the right time at the right place. We've kind of added formulation in there as well, and when Dave Rawlings talks later, you'll see why we think formulation should be part of that, because it's the right form of nitrogen as well. Now, the question of where does nitrogen come from? There's a statement down the bottom of the screen that says, if you want to grow 12 tons of any high performance pasture, if you do a simple sum, 12 tons times 3.2% nitrogen, which is what most of our pastures we aim to have in them, and you account for 2 to 1 above ground to roots, you come up with a figure of 600 kilograms of nitrogen per hectare per year required to grow 12 tons. So not a difficult calculation to do. And then you start asking the question, well, hopefully none of you would admit to putting on 600 kilograms of nitrogen on your pastures, because that would be horrendous. But it does ask the question, or it poses the issue that perhaps the amount we put on in fertilizer is only a small part of the equation, and we need to consider all the other sources of nitrogen when we do that. So how much comes in from dung and urine? Well, we know urine is a concentrated form of nitrogen, and the cows are recycling this back to the pasture, and that can be somewhere between 200 and 500 kilos of N that comes out of the back of the cow back to the pasture, albeit pretty inefficiently, which I'll deal with in a moment. If you've got legumes, if you've got white or red clover or another legume in the pasture, depending on the legume composition, you can have anywhere between 0, no legume, and 250 kilos of N per hectare per year in an ideal year coming in from the legume. It's another source of nitrogen. The soil itself has organic matter, and Dave will show some data on this. I'll show you some data on this, but there's a large amount of nitrogen that comes out of the soil organic matter in a year. And depending on the soil type and how much organic matter is there, you could get anywhere between 100 and 250 kilos of N per hectare per year out of that source. All right, so another source. Rainfall. Unfortunately, people overplay rainfall and they say, you know, a big thunderstorm and the pasture grows well. It's probably because it's water. But rainfall really, even with thunderstorms, only gives you somewhere between 1 and 7. So we've actually measured this, 1 in 7 kilos of N per hectare per year. Where I measured it in Gippsland, it actually made a difference as to where the wind was blowing from. If it was coming from industrial pollution, we got more. If it didn't come from industrial pollution, we got less. In the Netherlands, it can be quite substantial what comes out of the atmosphere. That can be up to 60 kilos of N per hectare, but that's because of a lot of agricultural emissions of ammonia that are coming back down. Whereas in Australia, we really don't have a lot of industrial emissions coming back down. And then you've got the question of fertilizer. And really, when you add up all those sources, you start understanding that 200 kilos of N as fertilizer per hectare per year is probably topping up rather than being the dominant input of nitrogen. So we've got to be smart about how we use that. Now, what I've highlighted there with the red stars is we've got to also split them into what is new input of nitrogen and what is recycling nitrogen. So really, legumes is new nitrogen coming out of the atmosphere, rainfall is new nitrogen, and fertilizer is new nitrogen. Dung and urine and soil is recycling of nitrogen. So we've got to think about it in those terms as well. All right, then the question is, where does it go? Well, how much can you harvest? I've put this in percentage terms, but we can talk about figures if you want to. How much is harvested? Well, that's the main idea, is to get it into the forage. So about half of the nitrogen might be taken up. Somewhere between 15 and 50% can be taken up into product. Unfortunately, when you start looking at the numbers, it's not very efficient, and how much actually lands up in milk. It's probably only about 15%. Then if you have a large runoff event, a cut-off low or something, you can lose nitrogen off the surface. Usually not more than about 10% of your annual nitrogen budget would go that way if you had a big event. Drainage can lose a fair bit. If you're on a very free draining soil, you can lose, say, 100 kilos of nitrogen per hectare on a sandy soil, can leach. On a less well-drained soil, it will be much less than that. And that can go out as nitrate, or it can go out in an organic form. If the organic nitrogen, or if the organic matter leaches, it'll take nitrogen with it. And then there's a bunch of gaseous loss processes. You can lose ammonia up to about 25% of the nitrogen, and you can lose it as either a nitrogen gas, which is most of the atmosphere you breathe as nitrogen, so that's probably quite benign. But you can lose it as a greenhouse gas, nitrous oxide. Again, a fairly small source of nitrogen. Now, if you add up all these percentages, it looks horrendous, but you've got to remember they're not all happening at the same time, and they're not all happening simultaneously. So you either are leaching or you're losing some of the gas. It very seldom happens simultaneously. So that's where it goes. But one of the challenges we've got is in our systems, only about 30 to 40% of the total N that's coming into the system ever actually completes the cycle and is fully recycled back to grow grass again. So unfortunately, and we've often said this, some of you might have heard me say this before, if we could capture all the urinary nitrogen your cows produce and spread it evenly back on the pasture, we probably would never need nitrogen fertilizer. It's actually because of the inefficiency in how the cows distribute the urine back to the pasture why we need nitrogen fertilizer. Now, let's have a look at these. Legumes, I call it a new source of nitrogen because it's fixing from the atmosphere. As I said, it can be anything from 0 to 250, because to get the upper end of that, you need to have at least 25 to 30% clover in your pasture mix through the warmer months of the year so that it can fix sufficient nitrogen to give you your 200, 250 kilos of N per hectare. Give you some ideas. I've got data only for Victoria, but there you can see, you know, in Gippsland, the average pastures has less than 12% legume. Now it needs 25 to 30 to get the 200, 250. In Western Victoria, even lower. Most pastures are well below 10% legume content. And you've got to remember that the bugs, the microbes that fix nitrogen out of the atmosphere in the legume, they're restricted by temperature. So when the soil temperatures are lower in winter, they are slower and so more available during the warmer months of the year. So in most of our pastures, we could be getting somewhere between 30 and 100 kilos of N per hectare out of legumes if you've got them there and they're active. Give you some idea. Soil organic nitrogen. Dave will show you some data on this, but it's a recycled source of nitrogen. So obviously this nitrogen that went into the organic matter is going to come out at some later stage. So it's nitrogen that went in maybe from dung, urine, fertilizer, captured in the organic matter, and then it'll come out at some later stage. Now, most of our pasture soils have a very large amount of nitrogen in the topsoil, somewhere 6 to 8 tons of nitrogen per hectare locked up in the organic matter. But Dave will show some figures later that only about 2% of this actually becomes available by microbes breaking down that organic matter in any one 12-month period. Again, restricted by low temperatures, so you get less in that in the winter, you get more of it in the spring. So again, the supply is somewhere between 100 and 250 kilos of N per hectare per year is going to come out of the soil, depending if you're on sandy soil or a clay soil, low organic matter, high organic matter, you can tell the difference. Here's some old data that I've got where all we did was take the controlled treatments in a nitrogen rates experiment. So this is just the total nitrogen extracted by the zero nitrogen treatment. In other words, growing Kikuyu with no nitrogen fertilizer, how much yield did we get and when did that arrive and how much nitrogen was in that yield to give some idea of what the soil was able to deliver. And what you can see here is first two things. One, the higher the soil organic matter content, so the 4% soil organic carbon soil was able to give us 180 kilos of N per hectare per year. The 2% was only able, the sandy soil was only able to give us about 90. But it's the pattern of delivery I think I want you to see. So it's the warmer months where there's moisture and temperature where you're getting more out of the soil. And in the winter months, you're not getting much out of the soil. So that you're starting to see a pattern here of where does nitrogen fertilizer fit in? It fits in when the other sources are not actually giving you anything. So let's talk about dung and urine. It's a recycled source of nitrogen, obviously, because it reflects what the animal's eaten, which is based on what was in the pasture. Now, for those people who say we shouldn't apply urea to our pastures, well, just remember that what comes out the back of the cow is largely liquid urea. Most urine that a cow produces, 69 to 90% of the nitrogen in urine is just straight liquid urea. Chemically, no different to the bag nitrogen. It's just unfortunately deposited in these highly concentrated patches. So a typical dairy cow urine patch can be somewhere between 800 and 1600 kilos of N per hectare per year equivalent sitting in the patch. So it's not surprising how inefficient that is in recycling, that only 40 to 60% of that nitrogen is lost and 40 to 60 can be used by the system. And also remember, even at a high stocking rate, it's probably only 25% of the paddock actually receives a nitrogen patch in any 1 year. So it takes you about 4 years at least to cover the entire pasture with a urine patch, and you have more deposited near the gate than you have at the back of the paddock, for example. So there's a case there, the redistribution. Now, this all distills down to one understanding here, and this is, I've just shown you a typical pattern of growth of annual ryegrass in the dark green. So you get the spring peak of growth, drops through the summer, and then you reestablish it in May. And you've got the pattern of white clover potential growth, or red clover slightly later. But you get the idea. White clover starts later than your ryegrass. It's really only starting to come away in the late spring period. And what this tells us, and Kikuyu would fill this gap in the middle here, that you'd have a bit of a bulge of Kikuyu growing there. But what I've done here is shown you the period of the year when we expect some nitrogen from clover to contribute to the overall grass growth. So you can see it depends on when clover is growing, and it depends on how much water there is during the summer period. If it's dry, not much nitrogen from the clover. If it's irrigated or it's rain-fed, you'll get some out of the clover. Same with soil organic nitrogen. It might start a little bit earlier in spring, so you'll get some in the September period, but then it's delivering that nitrogen over the warmer period. And it leaves you with a question of, if you want that extra growth out of annual ryegrass in the early spring period, well, soil nitrogen is not going to provide it actively for you. Clover nitrogen is not going to provide it actively. There might be some dung and urine returns, but you want that growth, you've got to put on nitrogen fertilizer to get it. Same at the autumn break or at the establishment of annual rye. To get that going, you'll need nitrogen to get it going, because natural sources of nitrogen are not going to be there to do that for you. So Marguerite, that's the introduction I wanted to go with. I'll hand over to Dave.
So Dave, onwards to you. Thank you.
All right, great. So thanks, Rich, for that introduction. So I suppose I'll be talking a bit more around some of the specific data, and I suppose summarising some of the experiments that we've been doing up in the subtropics, particularly around the Casino region, and looking at this transition from the rye into Kikuyu, and basically what happens to the fate of our nitrogen, and particularly this interaction with the soil organic nitrogen that Rich alluded to. So similar to what that graph that Rich just showed, a bit of just the inverse around the seasons. Coming out of winter, we actually have quite low organic nitrogen. So if we look at this graph here, we can see rainfall along the bottom. And then this blue line here is actually how much nitrogen is being removed from our organic matter when under a zero nitrogen treatment. So that's basically just what's being supplied from the organic matter alone. And coming out of winter, we're looking, quite low rates, around 5 to 10 kilos per hectare per grazing event. We get a bit of a peak in October as our temperatures increase. In this particular season, we went then into quite a big dry period, similar to what we're experiencing up here at the moment, where our rainfall dropped off, and so just simply our production dropped off. But what we saw then is this big east coast low come down and had this massive spike of mineralization associated with all that water, and basically all that, the profile got completely saturated. All the bugs accessed all the carbon there and started to break it down to release that nitrogen. So this is a big question then. So where does that nitrogen come from? So overall in this particular soil, from the supply from organic matter was 170 kilograms of nitrogen over the year. We can see a little bit of the timing here, but where does all this come from? And as Rich sort of alluded to, some of it's recycled from previous years, but a lot of it also is dependent on those new inputs of nitrogen. So when we actually feeding our pastures early in the piece, particularly in this ryegrass period in spring, actually some of that's carrying over, and then we're seeing that coming out later to feed the Kikuyu later. And similar to just the bottom down here, just similar to what Richard was saying, it really depends on the amount of supply, and also the timing of supply is really soil type dependent. At Camden, so down on a duplex soil where you might have a sandier topsoil over a heavier clay, you're looking at basically half the amount of nitrogen being supplied from your organic matter than you'd see in the heavier clay soils that we see in the alluvial zones, including up to 190 kilograms for Casino in that good black soil there. So this is sort of an experiment we did that allowed us to trace the fate of our added nitrogen through 3 grazing applications. So we applied, the typical 40 kilograms of nitrogen per hectare in one grazing event in sort of spring, and then we wanted to basically see, well, where did that nitrogen actually end up through subsequent grazing events. So we can actually look at, well, if we're applying fertilizer during that late spring period, how much is actually taken up during that time, and how much is carried over into subsequent grazings. And so in this case, we applied it in about September, and then we harvested it 3 times over the following 60 days. And so that's what we see in this graph. Sorry, let's move over controls. So the 3 different pies are the 3 different grazing events. So the first grazing event is over on the left here, and we got basically of our 40 kilograms of nitrogen that we added, the breakdown of what's in the soil, which is the brown, what is taken off in the first grazing event, which is this light green, what's remaining in the plant. So basically the below grazing residuals, roots is in the dark green, and what was actually lost from the system, so lost by those lost pathways which you mentioned, is in the yellow. And what we can actually see is, a fair chunk, so almost 15 kilograms out of the 40 kilograms, over a third of that nitrogen actually remains in the soil. So what we're actually doing is Basically 1/3 is going into the soil, and basically half goes into the plants, and a little fraction's lost. And actually, as we move through, and this is at the Casino heavy clay soil, as we move through to our second grazing cycle, we see that numbers don't change a lot. We get a little bit more taken up into the subsequent grazing. So now this medium green coloured here, so that's what was actually released in the second grazing. We got about 4 kilos, or about 10%, was carried through to the second grazing. Similar amount lost, so this is a cumulative graph, so no real difference in the losses between those two grazing events. But that fraction in the soil, dropped a little bit, but didn't actually change that much. And as if we go into the third event, we see a very similar pattern. So once again, the fraction that goes into the grass being removed declines. So we're down to below 10% now, and most of that is actually remaining in the soil. So basically, when we apply our urea fertilizer, pretty much 1/3 of it stays in the soil, and so it stays in there for at least 60 days in these soils. So we just look then at a similar soil, but this is the Camden duplex soil, so where we ran the same experiment. We saw slightly different dynamics in that actually we had a lot more uptake, almost half was actually taken up in the soil to begin with. Surprisingly, a lot higher losses. But then what was released from the soil from that first grazing was actually a lot higher. And so we basically, what was in our soil then halved, which is interesting. It just means that those sandier soils, they're a lot more responsive. They basically don't hold on to the nitrogen as well, which means that if there is a loss event, then they could potentially lose it quickly. And in that case, basically our losses accounted for more than 1/3 of our fertilizer applied. But our soil pool declined quite rapidly, but then stabilised into the second and third grazing. So once again, a fair chunk of our initial 40 kilograms ended up in the soil, but the sandy soil was less well, didn't hold on to that nitrogen quite as well as the heavier clay did. So this is sort of what happens in the short term. So I suppose if you're thinking about that last fertilisation, this is what we'd expect to see going into summer, that we would start to see some carry-on effect of the first two grazings after your last fertilisation event. The question then is, okay, well, what happens to this remaining 11 kilos or 8 kilos? This remaining basically 1/3 of the fertiliser you put on. So we did another trial. This one's from Gympie, so a bit further north, but similar sort of results we expected to see down south, where we actually followed the fate of that over the whole year. So the same sort of thing, but we just did it over one whole year. The top graph here, we have 2 different nitrogen rates plus a 0, and this is just biomass production. And as you can see, it sort of follows, starting low in ryegrass establishment, going up to peak production in spring, a bit of a dry late spring, December, and then a big rain event in sort of late summer. East Coast low came down and produced a lot of feed. So the interesting thing here is we still see a very big residual effect of the fertilizer even quite late into summer. So this dark grey shaded area, that's actually the non-fertilised period. So we only applied fertilizer during this spring ryegrass period. But we can see even as we get into sort of March, April, we're seeing some residual effects. A lot of spatial error in this case, but we're seeing some very significant effects of particularly from the 0 nitrogen of that urea carrying over. So that nitrogen that we put on in September and August is basically being carried over into late autumn, summer, and still feeding the Kikuyu even that time. And if we look at the bottom graph here, this is actually the percent of nitrogen that's coming from that fertilizer. So we use an isotopic tracer. We use a special label fertilizer where we can actually determine, did our nitrogen in our plants, did that come from fertilizer, or did that come from the soil getting matter? And you can see even in sort of late April, there was quite a big effect. And here we're looking at basically our conventional 40 kilograms per application. Once again, only applied in that spring period, following it through into the summer. And we basically had a full rate and a half rate. And we can sort of see that difference coming out in the Kikuyu yields. And even getting into sort of late April, we're seeing about 10% of our nitrogen still coming from that fertilizer nitrogen that was applied five months ago. So there's a big carryover effect in these systems. We do expect to see a fair bit of that nitrogen recycled into the Kikuyu. I suppose whether you want it or not, but that system that is certainly going to be stronger in heavier clay soils than the duplex or the lighter sandy soils, where we see a lot less carryover. That's the end of my first session, Marguerite. So I can hand back over to you.
Great. Look, thanks, Dave. I know there's some fairly complex graphs there that you presented, and some of them are hard to sort of, I guess, analyse and interpret just in that brief introduction to them. So I welcome at this stage, for anyone that wants to, just turn your videos on, unmute yourselves, don't be shy. And if anyone's got some initial clarification questions for Rich and Dave before we head on to having a look at just some strategies and some potential other ideas around product, then please do so. Just turn your mics on now and your videos and ask away. So do we have anyone?
Yeah, can you hear me, Marguerite?
Certainly can, James. Go for it. So we've got James here from Barrington. Go for it,
Yeah,
James.
g'day, everyone. Interesting graphs. Thanks for that. I'm just wondering what sort of rainfall the trial plots received over the from that sort of November period on, and whether that would have an impact, obviously, on that nitrogen carryover going into the late summer period.
Yeah, absolutely. So in the casino site where we showed that short-term carryover, it was actually irrigated, so it was pretty much non-water limiting the whole way through. Obviously, yeah, the more water that's going on, the more these processes are cycling through, the faster we expect that nitrogen turnover to be within a given soil type. At the long-term trial, which was over the full 12 months, we had a big dry period in that period of time, so that additional nitrogen was probably not picked up so early, at least as not early as it would have been otherwise. So certainly if you're not getting the pasture growth, the bugs are still there. They're still turning the soil over. Microbes can access soil moisture at much drier conditions than plants can, so they'll still be active even though your plants are shut off. And that's basically breaking down the organic matter and releasing that nitrogen. So if you're going into a big dry period, then you sort of expect to see even more of it released. And you just hope that when the rain does come again, that your plants then can grab it and take it up.
Thanks, Dave. Hopefully, James, that covers that, but ask away again in the next session as well with other questions, but thanks for picking up on that. Pete, Bill, you've got a question there. Can you go ahead?
Yeah, Dave, just a point of clarification on that. You had the soil type graph with the different percentages of nitrogen, and I think the heavy clay was 3%, but the other one was a bit higher, but the clay put out more. So to come back to bulk density, wouldn't it, that there's actually a lot more tons of organic matter in the heavy clay than the...
Yeah, I'll just share that again, just so we're aware what we're talking about. So, well, basically in this case, it was also farming practice. So the farmer at the heavier clay soil, even though it had less carbon there, he actually put on a lot more nitrogen. So the C/N ratio is not always fixed. It does vary a little bit, and in this case, it was actually a bit higher, just simply because he was putting on so much urea. The other thing to note is that this is basically just what we've picked up, so it doesn't also include losses. So this is what we've we've measured actually in our zero nitrogen treatments. It's that by no means everything is going on, so it's always just a bit of a rough indicator. But basically, that fertilisation history does make a difference there as well.